Alright, so let's look at this example. So it says like given the region enclosed by the curve x equals 2y squared, x equals 0, and y equals 3. Okay, so maybe the first part is we can sketch this region. Okay, so x equals 2y squared is going to be something like this. Okay, and x equals 0, which is this y-axis, y equals 3, it's something like this. Okay, so this is y equals 3, this is x equals 2y squared, this is x equals 0. Okay, so basically this is the region which is enclosed. Okay, what we can do here is we can actually solve the coordinates for this point. Okay, which we already know that the y coordinate, which is 3. Okay, we need to figure out the x coordinate. Well, it's also a point on this equation, so it's x equals 2y squared, and you see y equals 3, so it's 2 times 3 squared give us is 18. Okay, so this is 18. Apparently, guys, you know that the scale is not matched. It should be a very long and low curve. But anyway, you got the basic shape here. Okay, so now let's do part 2. And the problem is like this. So the revolve the region about x-axis, and then set up integrals using washer and shell method. Okay. Okay. So that's a problem here. Now let's draw it. This is probably more accurate. Okay, guys. Suppose this is the region here. This is the point. This is 18. This is 3. This is x equals 2y squared. This is y equals 3. Okay. If I revolve about the x-axis, it's going to be something like this. Okay, if you do the revolve. Okay. All right. So we can first maybe let's use the washer method. Okay. Let's use the washer method. And you can see that if I draw that, this is one of the cross section I can formulate it. Okay. So, the washer method, first of all, since this cross section is perpendicular to the x-axis, okay, and it's moving from 0 to 18, so our washer method is going to be from 0 to 18. Okay. And again, so it's pi times r, capital R squared minus pi times small r squared, and then dx, of course. Okay. So our capital R in this washer, as you can see, that it's equals 3 no matter what, right? So it's a constant. Our small r, which is, do you see that this is exactly the y, right? But I need to solve the y actually from this curve x equals 2y squared. But in this problem, I need to solve y in terms of x, because my integral is all about x. So solve for that. As you can see, x equals 2y squared. And you can see here is x over 2, and equals y squared. Okay, equals y squared. And you see, guys, for here, I can solve this r, which we only need to take the positive part, which is square root of x over 2, right? Because here y is square root of x over 2. We'll just take the positive part, as because it stands for the radius. So put all this back. This is from 0 to 18. Pi times 3 squared minus pi times r squared, square root of x over 2 squared dx. Okay. Turns out, if you simplify, it's going to be 9 pi minus x over 2 pi dx. Okay. So that's how we use the Washer method to do this. Okay. But if I want to use the shell method, okay. So again, let me draw some graph first, so that can help you understand better. Okay, so it's going to be something like this. Okay. So now draw very perfectly. Okay, so but as you can see, guys, this is going to be a washer. Okay, a washer. And so for the washer, our integral, because this is 3, okay, our integral is going to be with respect to y. So it's from 0 to 3 dy. Okay. Now remember, as a washer, as a shell, so this is my bad, shell method. As a shell, we need to actually calculate the shell. First of all, we need to figure out the height of this, which is purely just a y. Okay, which is purely y. So that's easy. And so the circumference, which is 2 pi times y. Okay. And then the height of this shell, which is going to be the distance between here to here, you can see that it's exactly x. And I need to write x in terms of y, because my integral is all about the y. And we get the perfect setting, because this curve, remember, this is x equals 2y squared. So 2 pi times y give us circumference times the height, which is 2y squared, times dy, which is the thickness of the shell. That gives us the answer. So it turns out using the shell method is much easier. So we got 2 pi y, well, actually it's 4 pi. Okay? 4 pi, 2 times 2, and then y cubed dy. Okay? This is very easy to set up. Okay. Alright, so now let's continue to see that, well, what if I revolve about, let's see, y-axis? Can you use the shell and the washer to handle it? Okay. So now let's take a look. This is 3. X equals 2y squared. Okay. And you can see that if you if we do that, you know, in fact, guys, in this problem, if you're going to use the Washer method, it should not be a Washer method, but instead it's going to be a disk method, right? Because think about this. The cross section that is perpendicular to the y-axis is going to be a disk instead of washer. Okay, so that actually makes things much easier. So let's see, disk method, okay, which is integral from 0 to 3 dy, okay. And as long as I can find the radius of this in terms of y, I'm good to go. And it turns out that we got the perfect information because this part, which is exactly x, okay. And I know that x equals 2y squared. So my radius in this cross section is going to be 2y squared. So it's 2y squared. And then square it. Okay, remember the disk method is to figure out the radius. In this problem, the radius, which is 2y squared. So the area of this disk, which is pi times r squared, which gives us is pi times 2y squared. And then that's how we put it here. Okay, of course you can simplify this, which is from 0 to 3. You're going to have 4 pi y to the power 4 dy. Okay, so that is using the disk method. It's pretty straightforward. Now, if we try to use the shell method. Okay, and this is going to be the shell. Okay, it's going to be a shell. Okay, and of course this is this part is 18. Okay, okay, so this is the shell. If the shell method, there's one thing we need to know, that we have to make the integration about x. Okay, and you know, as long as you know the height, the radius, which is just x, so it's 2 pi times x give us the circumference, and then times the height. Okay, the height, guys, as you can see in this problem here, so the height can be the difference between y equals 3 and x equals 2y squared. Okay, so that's going to be the height. So this is y equals 3. This is x equals 2y squared. In other words, we actually need to solve y here in terms of x, and then to complete this problem. It turns out that we solved that, right? So x equals 2y squared. We only take the positive pieces. So x over 2 equals y squared, and then y equals square root of x over 2, okay? And, you know, then we can get the height, which is 3 minus square root of x over 2. And, you know, the circumference, the height, the thickness of the shell. So this gives us the volume of the shell. Make an integral from 0 to 18, and then we done. Okay. So that's the example if we do the revolve about y axis. Okay. Now maybe let's increase add 2 more pieces here. Let's call it a power 4, and this is what we're going to do. So what if I revolve the region about x equals -1? Okay. And the same thing use, the washer and shell to handle this. Okay, to handle this. So that's a problem here. Okay, now let's draw this again. Remember, this is okay. So right now, this is -1. So it turns out that the graph can be something like this, okay? Because, again, bad drawing, okay, but you got the point. But right now you can see that if we were going to use the washer method, okay, and as you can see, guys, here, the cross-section, okay, it's like this. And, so our cross-section is still moving between 0 to 18. So this is our preset up, something dx, okay. And we know it's pi times capital R squared minus pi times small r squared here, okay. So our capital R x in this problem, as you can see, this it's a distance. Maybe use different. So this capital R, it's you see, actually it's this length. Okay, so this is -1. Okay, so this is 3. So as you can see that the radius, the capital R radius, which is the distance between y equals 3 and y equals -1, turns out it's 4. Okay. Similarly, our small r of x, which is going to be the difference between this and y equals -1. Okay, actually we can, you see guys, we can borrow some results here. Okay, remember from part 2, if we just revolve about the x-axis, and then our radius is going to be square root of x over 2, okay, which is just to solve this. And if we revolve this with respect to x equals -1, because well, this should be y, okay, y equals -1. I apologize for this. And if it's revolved about y equals -1 here, and the corresponding radius is going to be square root of x over 2, which is just this part, and minus -1, right? And also you can think about it's add a 1 here, so it's just a plus 1. So that actually give us this problem. So plug all of this in, it's going to be from 0 to 18, pi times 4 squared minus pi times square root of x over 2 plus 1 and square dx, okay? So again guys, apologize for this. The first part should be, we'll revolve this region about y equals -1, okay? So this is how we get to using the washer method. And if we use the shell method, again, still want to draw this. This is y equals -1, and this is -2. Something, right? Like this. Okay, so if we're going to construct a shell, so you can see, so if you imagine that, this is going to be a shell. So so for that shell here, guys, you can see this is from 0 to 3. So our integral is going to be integral from 0 to 3 something dy, okay. Like we said, to have a shell, to figure out a volume of a shell, here, we need to figure out the radius, r, we need to figure out the height, and then also we have the thickness of the shell. We already know that it's going to be dy, okay. So our radius in this problem here, as you can see, it's just a y plus 1. Okay, so the radius in terms of y, which is y plus 1. And again, you can do a comparison with what we just did from the previous part, which you can see that if we use the shell, if we revolve just above the x-axis, the radius is y. But right now, when we revolve about y equals -1, so the radius is going to be y plus 1. Okay. And then the height, actually, it does not change, right, guys? Do you see that? Let's do a comparison. If you revolve about the x-axis, or you revolve about the y equals -1, you can see that the height, it does not change. It's just still it's x, and we know that this is x equals to y squared. Perfect thing to our height. This problem is going to be in terms of y, it's 2y squared. So with all of this, what we can get is we can put it in, so it's 2 pi times y plus 1 times the height, which is 2y squared. So that is how do we use this shell method. Okay, with the shell method. If we revolve this about y equals -1. Okay. So now we talk about this and this. Maybe let's talk about the last situation. Well, what if I revolve the region about x equals -1. Okay, so in other words, that's going to be the region. Okay, so this is -1, and apparently you can see this is going to be -2. Okay, it can be something like this. Okay, it's going to be something like this. Okay, of course, this is 3. Okay, so all right. So if we trying to use the Washer method, and you can see that if we draw a cross section, it's going to be something like this, right? It's going to be something like this. So if we use the Washer method, we're going to set up our interval in terms of y. So it's from 0 to 3, something dy. And again, we need to figure out the capital R. We need to figure out the small r. Okay, the capital R here, which actually, let me use a different color, give to you, which is exactly this species, right? So the difference between this curve and x equals -1. Okay, so we know that this is x equals 2y squared. And it's already in a perfect format. This part is just a 2y squared. And then as long as you add a 1, that'll give you the bigger radius. Okay, so this r is going to be 2y squared plus 1. Okay. And if you look at the small radius, actually you can see that no matter how you move up your cross section or move down your cross section, the small radius is fixed, which is just a 1. That's And so just need to plug in, so it's from 0 to 3, pi times 2y squared plus 1 squared minus pi times 1 squared, which is this pi, okay? And then dy. So that's how do we handle this using the Washoe method. Now if we try to use the shell method, you can see that, guys, I draw a lot to explain any problems, and I hope you do the same thing, okay? Again, bad drawing, but you got the point here. So let's construct a shell here, guys. Okay, so that's going to be something like this, okay. Now, I want you to do a comparison with, if we just, revolve this part about the y-axis. You can see that the height we calculated out, which is 3 minus square root of x over 2, which is the difference between those two. It turns out that, guys, take a look. Okay, take a look. Even we revolved about x equals -1. Do you agree that actually the height does not change, okay? And so the integral is from 0 to 18 something dx, and it's 2 pi times the radius, okay? I haven't know that, but the height, I already know it's the same thing, so it's just a 3 minus square root of x over 2, same height, okay? So right now the only little thing part is, what is my radius, okay? And let's use a different marker here. As you can see, guys, the radius, which is exactly this piece. In other words, the original radius was just x, but for here, you need to add a 1. So you put a 2 pi times x plus 1. That is the radius here, times the same height as we discussed. 3 minus square root of x over 2, and then times dx, that's the thickness. So that gives you the volume of that shell, and integrate from actually from 0 to 18. That is the shell method, okay? It's a pretty long problem here, but it's I think it's a very good practice for you to be crystal clear about what's going on, related to shell and washer. Okay, I hope you enjoyed this. I'll stop here, and I'll see you next time.